Hello! I know you walked in, you thought Mr. Larkin's not here, but he is. Okay, so you're working on your do nows. Make sure you copy the objective, answer the do now before moving on. Pause this video, and once you're done and ready to discuss the do now, unpause it. Okay, so list as many properties of metallic compounds as you can. So you should have come up with something like this. They have a low electronegativity. They conduct heat and electricity. They're malleable, which means they're bendable without breaking. They have a metallic luster, or they're shiny. And they have a medium strength bond, which means they have a medium melting point. It's not low, but it's not exactly high like ionic either. Okay, turn to page 3.19. Discuss these test your understanding questions with your partner and be ready to report out. Ask for responses for each one and discuss it, and then play the video and I'll provide an answer. Okay, so work on number 1, 2, and 3. Discuss number 1, play the video. Discuss number 2, play the video. Discuss number 3, play the video. Go ahead and pause it. Okay, so number 1, where are the valence electrons in a metallic bond? So the valence electrons wander freely through the metallic bond. Now, that doesn't really tell us why, so why? The electrons are not held in one place because metals have a low electronegativity, and thus the electrons can wander around. Okay. So go ahead, discuss number 2 as a class, and then you can unpause the video, so you should pause it now. Number 2, explain what holds metal atoms together. Metal atoms are held together because the metal cations are attracted to the sea of electrons. Electrons are negative, so they form a field of negative charge. Cations are positive, they're attracted. Okay, so there we go. Discuss number 3 as a class. Make sure to pause the video, and when you're ready, unpause it. So number 3, why can metals conduct electricity? Well, it has to do with the electrons. Metals can conduct electricity because electrons are free to move around. Let's add a little bit about why that is. We can say due to metals' low electronegativity. This is kind of a similar question to number 1. Right? It's a similar answer, I suppose. What are the electrons doing? Where are they? Well, they're moving freely. That's what allows metals to conduct electricity. Okay, so we've got these 3. Moving on. Now that you've discussed page 19, let's do a little practice. So you're going to be working on page 320 with your usual groups, which I'll show in a moment if you've somehow forgotten. It should take you 15 minutes, 20 max. If it takes longer than 20 minutes, group leaders just bring each other back to the lecture side of the class. You need to bring page 20, your periodic tables, pencils, and you need to be responsible. Let's keep in mind it's all about the learning. I'd be very disappointed to hear that you're goofing off in my absence. Okay, so here are the groups if you've forgotten. It'll switch every 5 seconds. Okay, so you're back from working in your groups. You're going to be working on a challenge problem now. work on page 3.21 with your partners. I'm going to go over the answers in 15 minutes. Go ahead and pause the video now and unpause it in 15 minutes. Okay, you've worked for 15 minutes with your partners. Let's go over the answers here. So A, draw a possible representation of the metallic bonding in brass. From the reading, we know brass has zinc and copper. So metallic bonding doesn't have a set structure, so we know there's just going to be a whole bunch of copper and zinc split around. Okay, so I'm going to draw a couple more. But if it were just all these positive charges, they would repel each other very strongly. So we've got to remember there's a sea of electrons. These electrons don't have a particular pattern, so I'm just drawing them semi-randomly. And I wish there were some way to convey that these electrons are moving randomly around and creating this field of negative charge, but I don't know how to communicate that kind of motion in a static drawing like this. But this would be a possible representation. Now, if you had different numbers of copper and zinc, or if you had them slightly less structured, that actually might be better. That's fine. Just the core aspect is you need some zinc, some copper, and then you need electrons around. B, why is brass able to conduct electricity? This is very similar to the reading question from before. So we can say brass is able to conduct electricity because electrons are able to move freely. Oh, went off the page there. Now let's say, why is that? We can say, so electrons are able to move freely because metals have a low electronegativity and do not hold onto the electrons. Alright, and so therefore metals conduct electricity very well. Brass is a metal, it's a metallic bond. Part C. Why doesn't an alloy need to have a constant ratio of the metals in the compound like ionic or covalent would? Think about electrons. Alright, so ionic and covalent, let's go back. All bonding is trying to fill an octet. Let's actually write that. So all bonding exists so that atoms achieve full valence shells. Now let's think about metallic bonding. Metallic bonding, or let's say metals in metallic bonding, how do they get a full shell? Well, they get a full shell by losing their valence electrons. These electrons, remember, just go into a sea of electrons. So does it matter where they go? No. So they're not going to something else that's filling its octet. They're not being shared with anything. They're just going to a sea of electrons. So it doesn't matter how much of the other chemical, the other element you have, because the electrons are just going into the sea of electrons. So let's try and communicate that. Right? So they're losing their valence electrons. These electrons are going into a sea of electrons, and it isn't important how many. Let's go back. So these electrons are going into a sea of electrons, and it isn't important how many other metals there are. They don't interact. Right? All that matters is that the metals lose their valence electrons. So as long as every atom has lost its valence electrons, it doesn't care what all the other atoms do. So they don't have a constant ratio. Okay, D. Diagram and describe the bonding that takes place in zinc chloride. Assume zinc has 2 valence electrons. So this is a metal and a non-metal. So before, I'm going to have zinc with 2 electrons, chlorine. It has 7. I know that there are 2 chlorines because there's a subscript of 2. Whoa. Okay, so what's going to happen here? Well, chlorine has a high electronegativity, so it's going to take electrons from zinc. This chlorine has a full octet now, and now does this chlorine. So that leaves zinc having lost 2 electrons, which means it forms a +2 charge. And chlorine gains 1 electron each, so that's a -1 charge, but there are 2 of them. Okay. So now we need to discuss this bond. It says discuss the electronegativity, so I'm going to say zinc has a low electronegativity, and I know that chlorine, right, and chlorine has a high electronegativity. It says discuss the electrons. So I can say zinc loses 2 electrons, comma, 1 to each chlorine atom. It says discuss ions present. Say zinc forms a +2 ion, there we go, and chlorine forms a -1 ion. And then the structure, we can say the ions attract each other and form a crystal lattice, because this is an ionic bond, so that means we have a crystal. Alright, so there we go. We got our diagram, we got our description. Very good. So if you're in periods 4, 5, and 6, you're going to work on questions 1 through 10 at the bottom of page 3.18. This is something we didn't get to last week. Periods 1 and 2, you're going to skip a little forward in the video, and you're going to work on some whiteboard questions. Okay, so if you're periods 4, 5, and 6, work on 3.18. Pause the video now. If you're periods 1 and 2, skip over the next slide. Okay, if you're still with me, that means your periods 4, 5, and 6. You should have already worked on page 1 and 10, or questions 1 through 10 for about 10 minutes. And I'm going to go over the answers now. If you haven't worked for 10 minutes yet, pause it and unpause it after 10 minutes. Okay, here are the answers. We got NaF, sodium fluoride, K2S, potassium sulfide, NiSO4, that's nickel 2 sulfate, Al2O3, that's aluminum oxide, CaCO3, that's calcium carbonate, NH43P, that's ammonium phosphide, CuNO3, that's copper 1 nitrate, CuNO3 is copper 2 nitrate, because it would have to have a +2 charge. PbO2 is lead 4 oxide, and Li2S is lithium sulfide. Go ahead and pause it if you need to discuss or explain some of these to each other. If not, keep moving on. If you're periods 1 and 2, skip over these whiteboard questions. If you're periods 4, I'm sorry, I just said that wrong. Periods 1 and 2 are going to do the whiteboard questions. Periods 4, 5, and 6, skip over them. Okay, so periods 1 and 2, on your whiteboards, what would the name be for Na2CO3? Pause the video till you're ready to discuss it. Okay, Na2CO3, I know that's an ionic compound because CO3 is a polyatomic ion, it's carbonate. So these ones are actually really easy to name. You just do the metal and then the polyatomic ion. So this would be sodium carbonate. Okay, let's do the next whiteboard question. What would the name be for N2O5? Pause it till you're ready to discuss. N2O5 is a covalent compound. I need to name it using prefixes then. So there's 2 nitrogens, so that's dinitrogen. And then there's 5 oxygens, so that's penta. Then we have to change it to oxides. So dinitrogen pentaoxide is what this would be called. Let's do the next whiteboard question. What is the formula of gold 2 nitrate? Pause it, and when you're ready, we can go over it. Okay, gold 2 nitrate. So gold is Au. It is a 2, so that means It's a positive 2 charge. Nitrate is NO3. It has a negative 1 charge. You got to memorize that. These are not currently balanced. We need one more negative. So that means the subscript for Au is just 1. There's no subscript. And NO3, there are 2 of them, so we have to use parentheses because it's a polyatomic ion, and we put a subscript 2. So that would be the formula. Let's do the next whiteboard question. Number 4. What is the formula of potassium phosphate? Pause it until you're ready to discuss. Potassium phosphate. Potassium is K. Phosphate is PO4. Potassium forms a +1 charge. Phosphate forms a -3 charge. It just always has a -3 charge. These are not currently balanced. I need a lot more potassium. Got to add 2 more. So that gives me 3 total potassiums, 1 PO4. Since there's only 1, we don't need parentheses. This would be the formula, K3PO4. Okay, so all periods, you can use leftover time to work on the homework that you picked up or your action plans. Remember to come in and do some retakes with those action plans, put them to use. Once there are about 10 minutes left in the class, maybe 7, leaders please pass out exit slips and have students work on those. So you can pause the video until it's time for exit slips. Okay, so it's time for exit slips. Please pass them out, work quietly, and wait until everyone's done. Unpause the video when you're ready to grade. Alright, trade exit slips with each other. Have a pen out. Here we go. It says, describe the bonding within a gold necklace. So I'm looking for a couple things. So one thing is that you mentioned that gold, because it's a metal, has a low, you could say electronegativity as well. I said ionization energy here. Next is what's happening with the electrons. Well, it's a metal, so it loses its electrons. Okay. And then, what else is true? Well, the cations are stuck in a sea of electrons. What I really want to know, though, is that the electrons move freely, because so many of the properties of a metallic bond have to do with the fact that electrons are free to move around. So you can put this out of 3. Please pass it up. Make sure your names and periods are on it so I can look at it and see how you did on this lesson. If there's any leftover time, use it on your homework. And once the bell rings, you're dismissed. Please push in your chairs. I look forward to hearing a good report of how the class went.